In the viewable portion of space, there are potentially a septillion stars, making the total number of stars in the universe almost infinite. However, it is unlikely to determine an exact figure at this time or in the future. Hello and welcome to AWZ News. Please don't forget to subscribe and hit the bell icon. Today's topic is not stars, but rather the larger structures that comprise them. As we know, stellar systems, along with their rarefied gas and dark matter, form gravitationally bound structures called galaxies. According to various estimates, humanity can currently observe several hundred billion of these structures at different stages of their revolution. Let's talk about some of the most unusual ones, starting with the Milky Way, which is the first object in outer space. The distance between the Milky Way and other galaxies is generally mind-boggling, ranging from millions to billions of light years. This is because the universe's cosmological expansion causes the distance between Earth and any distant object in the universe to grow constantly, giving it the appearance of being redder than it really is. This phenomenon, called a redshift, is very useful for measuring velocities and distances on an astronomical scale. Alternatively, the spectrum of some galaxies is blue-shifted, indicating that they are traveling toward us rather than away from us. One of these unusual space objects is the galaxy M86 in the Virgo cluster, roughly 52 million light-years away from the Sun. It is moving towards the Milky Way at a speed of around 244 kilometers per second, which makes it one of the fastest-moving blue-shifted galaxies by moving at high speed through the scattered gas. The Virgo cluster is filled with M86 is constantly shedding its own interstellar matter. As a result of this process, it leaves a trail of long lines of warm, ionized hydrogen behind M86 is connected with the almost destroyed spiral galaxy GC 4438. With several of these filaments, these two galaxies are thought to have collided at some point in the distant past, which was the smaller one's undoing. Interestingly, M86 is known to have destroyed its other neighbors in the past, as well. Several stellar streams have been detected in its halo that are likely to be the remains of smaller galaxies absorbed earlier. An impressive number of globular clusters in its structure is another outstanding feature of M86. Observations show that their number is upwards of 3 and 800, which is around 25 times as many as in the Milky Way. There is a theory that claims these clusters to be the remains of dwarf galaxies that M86 would have absorbed in the past. If it really is the case, then it would have destroyed tens or even hundreds of other galaxies. Having said that, M86 looks anything but unique. We'll examine the second galaxy, 137-001, which shares a similar shape with M86 but appears more bizarrely original. Located 227 million light-years from the Sun, its mass ranges from 5 to 14 billion solar masses. The majority of its stars are youthful, brilliant blue giants. ISO 137-001, in turn, is a component of Able 3627, a large galaxy cluster traveling towards its center at a remarkable speed of nearly 2,000 kilometers per second, collides with the interstellar gas pressure within the cluster, causing its own gas to burst out, resulting in tails extending up to 260,000. Interestingly, the mass of interstellar gas in these areas is 2 to 4 times that of the galaxy's internal gas. This means that stars continuously form in these massive hydrogen-dominated streams, making 137-001 resemble a giant jellyfish floating through endless expanses of space. Unfortunately, as these galaxies continuously lose their interstellar gas, their life expectancy diminishes, preventing the formation of new stars, a process that significantly influences the structure of the galaxy's spiral arms and central bulge on the bright side. Scientists have a chance of finding out more about dark matter and its interaction with other space objects by observing the behavior of the gas streams left in the galaxy's wake. In terms of star formation, a galaxy aptly named Baby Boom serves as a prime example. Baby Boom. This region gives birth to about 4,000 stars annually, or roughly 400 times more than the Milky Way. The Baby Boom galaxy is located approximately 12.2 billion light-years from Earth, meaning that what we see is what was happening just 1.5 billion years after the hypothetical Big Bang, a period of time when the universe was still forming its structure. Simple calculations reveal that an old star in this region of space lights up on average every 2 hours. Although the current state of the galaxy differs greatly from what theory predicts based on our understanding of star formation, it is undeniable that the baby boom generation can teach us a lot about the early phases of our universe's evolution. We still don't know why this galaxy produces stars at such an astonishing rate. One of the few galaxies visible with an amateur telescope is the so-called Sombrero Galaxy, officially designated M104. It is located 30 million light-years from Earth and has a diameter that is about 4 times smaller than the Milky Way. The massive ring of dust and cold hydrogen that surrounds the Sombrero Galaxy is what makes it unique. The majority of young stars are born here, according to observations, and the Sombrero Galaxy is notable for more than just its unusual ring. Its complex internal structure is also noteworthy. The majority of the stars in this galaxy, according to observations made with the Spitzer Space Telescope, form an elliptical galaxy's typical structure. These stars are primarily very old yellow and red dwarfs. The other stars, on the other hand, form spiral structures hidden by an elliptical cloud. It is believed that this phenomenon arises from the collision of two galaxies, leading to the eventual mingling of their stars. It's amazing that the galactic structures survived a merger of that magnitude with little damage and are still visible today. Another oddity is the extraordinarily strong X-ray radiation that emanates from the center of the Sombrero Galaxy, thought to originate from the accretion disk of a supermassive black hole. Scientists estimate the mass of the hole to be over 1 billion solar masses, making it one of the largest black holes known to science. Scientists have detected several sources of extremely high-frequency radiation, or terahertz radiation, within the galaxy, but their nature remains unknown at this time. Our galaxy procession comes to an end today with yet another item that has a complex internal structure. The number of black eye stars in the Erie M64 galaxy, aptly named the Black Eye Galaxy, is impossible to estimate, but we do know that it is relatively small and not too far away from the Milky Way. Its radius is 25,000 light-years, and it is located about 17 million light-years away from the Milky Way. Two distinct parts compose the galaxy. The name, Black Eye Galaxy, is derived from a dark band of cosmic dust that partially conceals the galaxy's center from an observer on Earth. The most likely explanation for such a bizarre composition is that the galaxy formed after two smaller ones collided and merged in the distant past. Admittedly, it would take a combination of a number of mutually independent factors for such an interesting and well-defined structure to form. For example, if the progenitor galaxies had moved at specific velocities and come together at a certain angle, the odds of success would have been minuscule. Interestingly, the inner disk with a bulge rotates in the opposite direction of the outer ring. These hundreds of billions of galaxies, composed of countless stars of all sizes and types, from tiny dwarfs to supergiants, collectively form our wonderful and mysterious universe. If you're interested in learning more about it, please subscribe to our channel if you haven't already, and keep an eye out for our upcoming, hopefully amazing videos. Let's stay in touch. Thank you for watching.